Hi everyone, this is the very last section of Chapter 8, so this is 8.3, and you will be learning about net ionic equations. You will need your own piece of paper, and go ahead and copy this equation down and balance it. So remember, when you balance the equation, we can only add numbers in the front. Okay, so let's take a look. So we have one lead here, one lead there. Okay, so the leads are balanced. We got 2 nitrates on this side and only 1 on that side. So what do we have to put in the front to make that one 2? So we just put a 2 in the front. But notice when we put that 2 in the front, it also changes the H's to 2. So we look on the other side and it's already balanced. There are already 2 H's on that side, so that's good. 1 sulfate, 1 sulfate. So that's it. We only needed a 2 in front of the nitric acid to balance it out. So everything that we just wrote down here, this is what is called the molecular equation. So let's write that down. So this is the molecular equation. All right. Okay, so before we move on, what type of reaction is this? So you have a choice: combination, decomposition, single replacement, double replacement, or combustion. All right, those are your choices. So it is a double replacement reaction, okay, a double replacement reaction. So you can see how the outer ones come together. Remember, it's like doing FOIL in math. So first the outer, and then the inner ones come together. And so everything that I am going to be teaching you in this lesson is for double replacement reactions only. Okay, so all this net ionic stuff, once again, is only for your double replacements. All right, the next thing that we're going to do is we are going to write out what is called the complete ionic equation. All right, so complete ionic equation. When we write out the complete ionic equation, we are going to look at the states of matter that are already listed here. And so what does AQ mean again? AQ means aqueous. It is dissolved in water. So this is dissolved in water. This is dissolved in water. This is your solid, all right? S stands for solid. And this is what we call a precipitate, okay? Precipitate. So let's write that down. Precipitate. And basically a precipitate does not dissolve, or it dissolves very, very, very little. It's basically a solid that forms in solution. And then this last one here is aqueous, so this will dissolve in water. All right, so for the complete ionic equation, for everything that is aqueous, it separates into ions. That is what it actually looks like in solution. It doesn't stay together in the molecular form at all. It actually will separate, okay? But the solids will stay together in solution, all right? So everything that is aqueous, we are going to separate into ions. For everything that is a solid, it's going to stay together. So what I like to do is I like to box up the solid. By boxing up the solid, that is telling me that I'm going to keep it together. And then everything else, I'm going to separate, okay? So this is what it's going to look like. PB, and we need to write down the charges, okay? We need to write down the charges. So in this case, the lead has a +2 charge. And I know it has a +2 charge because there are 2 nitrates in this chemical formula, and nitrate is a polyatomic ion with a -1 charge. So therefore, this lead has to be +2. Okay, so the lead is +2. That separates. And then watch what I do with this 2 that's on the outside of the parentheses. I'm going to move this 2 to the front so it's a coefficient. So it looks like this. And then nitrate has a -1 charge. Okay? All right, and then we go to the next one. There are 2 H's. Once again, bring this 2 to the front so it's a coefficient. So 2 H's, and hydrogen has a +1 charge. And then we have the polyatomic ion, sulfate, and there's only one of those. So you want to keep your polyatomic ion together, and sulfate has a -2 charge. All right, so everything that was aqueous, we just separated into ions. Now this is a solid, so this one stays together. And so I'm going to box that up to remind me that I have to keep that one together. And then this last one over here is aqueous, so I'm going to separate that into its ions. So H+, because hydrogen has a +1 charge, and then I'm running out of room, so I'll just write it down here. Nitrate, and that is a -1 charge. Okay, so that is your complete ionic equation. Once again, you separate everything that is aqueous into its ions, and then the solid you keep together. Now the last thing that we're going to do is called the net ionic equation. Net ionic equation. Okay, so for the net ionic equation, we are only going to write down what is left. So we're going to go through and we're going to look at everything here, and we're going to reduce this equation down. Okay, we're going to reduce the equation down. Whatever we have the same on the left and on the right-hand side of the arrow, we can cancel out. Okay, we can cancel it out. So we just take one thing at a time. So we have a lead ion here on the left side of the arrow, but we don't have a lead ion on the right-hand side all by itself, so we can't cancel that out. Here we have 2 nitrates. Oh, and I forgot. Let's go back. Remember, notice how we put a 2 when we balance the equation there? So that means that we're going to carry that 2 through those. So I need to put a 2 in front of there and there. So I forgot to do that. All right, so then that should be 2 H pluses and then 2 nitrates. Okay, so that's better. All right, so let's go back. 2 nitrates here, and then we have 2 nitrates on that side. So we can cross those 2 nitrates out. Okay? Then we have 2 H pluses, 2 H pluses. So we can cross those out on both sides. And then we look at the last thing, sulfate by itself, and we look over here, and we don't have sulfate all by itself, all right? So we can't cancel that out. So then I'm just going to box up what we have left so I can easily see what is remaining. So the net ionic equation is whatever I boxed up, whatever is left. So whatever I did not cross out goes into the net ionic equation. So therefore, let's write it nicely. It would be Pb with the +2 and the SO4 with the -2, which gives us the lead sulfate. Okay, so that is the net ionic equation. And your equation should make sense, okay? Should make sense, and it should be balanced also. So if this is our solid, then you have to have those 2 ions come together to make that solid. All right, so the equation has to make sense, and it should be balanced also. Now, the very last thing that we have to do, we have to write out what or identify, I should say, what the spectator ions are. So let's write that down. Spectator ions. All right, so the spectator ions are basically the ions that we crossed out. Okay, so the ions that we crossed out. So that would be the nitrate and the hydrogen ion. So we can just list them. You don't need to put the coefficients in front of them, just list them. So the nitrate and the hydrogen ions. So spectator ions, we call them spectators because they are just watching the reaction happen and not really participating. So once again, this is the reaction that's taken place, and so they're just watching that happen. Just like spectators at a sporting event. They're not really playing or participating. They are just watching the game. Okay? So just like the spectators, they are watching the game, and that's the game right there. Okay, so that is it. That is the lecture on net ionic equations. And we will do more practice problems in class so that you can get the hang of this. All right? All right, see you later. Bye.